So, no, it's not. It's a bad thing, but it's a bit. I'm not that used to this kind of thing, so it's an interesting experience. Okay, so yeah, I'm Colin Hemmings. I'm a co-founder at Dataloop.io. We're a kind of a monitoring startup in London. I'm responsible for engineering, so I look after the team, make sure we're kind of working on the right things, and going generally in the right direction, not just faffing around, playing around with different technologies. Primarily got a development background for 10 or so years now, but I did have the enlightening experience of working for a couple of years in a DevOps team. They were some of the most brilliant, high-functioning alcoholics I'd ever worked with. During that time, we're kind of mostly involved with automated deployments, building a deployment portal, and working in monitoring. So yeah, it was a kind of new task for me, primarily working in normal application development. So we set about this task. There's loads of cool open source technologies. We're brand with AWS, using all these different technologies. And yeah, it went well. Started plugging it all together. It was great. Had some fun with dashing JS, building dashboards. But yeah, and after a while, it started to get a little bit complex, and you just kind of take a step back, and you've got this kind of horrendous spaghetti of different monitoring applications going on, and it gets a bit kind of unwieldy to deal with. So in 2013, we founded Dataloop.io. We thought we'd kind of make things better. We kind of make it easier to collect and visualize and alert on the different data you've got coming in. There's a lot of kind of information in there, so we wanted to make it easier to get that out and be able to put it in the faces of the different members of your organization. We also wanted to make it easier to be able to collaborate around monitoring, so that you can do an initial setup of your monitoring stack that's kind of controlled by a ops team that know what they're doing, but then they can devolve parts of that down to the development. So people that probably don't know what they're doing from an ops background, and still let them monitor their different services, especially in teams that are dealing with microservices. So a core part of Dataloop.io is dashboards and general visualization, as it should be with most monitoring tools. If you can't see the data, if you can't get at the data, then it's not really providing any value. And yeah, if you can't alert on the data, it's not much value either. But whilst we were building this, we spoke to several different companies. We've got a blog post out there about the 60 companies we talked to whilst building the application. And there was some kind of general types of dashboards that we saw. And yeah, I thought we'd kind of give a little bit of an overview of those. So the first type was the kind of standard analytics dashboard. This is primarily used by ops and dev, really, to diagnose performance issues, general problems they're having in the application. Really low level, detailed performance type metrics. So when you've got a particular problem in your application, you can use the low-level graphs to kind of correlate what's happening, and give you a really detailed view of your application. The other type is the NOC dashboard. Again, these are quite high-level, general overviews of your individual services. They are really good at giving you an at-glance view of what's going on, whether you've got any slight issues, whether something's completely fallen over. And these tend to be in NOCs, in support areas, so people can kind of see what's going on straight away. If there's an issue being reported, they can tell if there's a particular service failing or having some problems. Or if they're just walking by, they can kind of see something before maybe a customer notices it. A new kind of one is what we kind of call the team dashboards. These tend to be centralized, oriented around services as standalone entities on their own. So you get quite a mixture of different types of data in there. You get some still high-level performance metrics, some different statuses for your application, but you also get a mixture of marketing and business type metrics in there as well. So if you've got a a payment service that makes up part of your company's offering, then you can see, how well that's performing, how much actual money is coming in, how many people are abandoning a purchase halfway through, so how much money you're kind of losing as a result of performance issues or UX problems. So these are, tend to be team-oriented. They go into your general dashboard stack. But yeah, they're an overview of everything, not just technical things. Another one is public dashboards. These tend to be, as the name suggests, public in public areas of your company, so in receptions and things like that. They tend to be, again, really high level, but simplified, sanitized dashboards. You're not going to use these for diagnosing production issues. As you see in this example, they've got a general Twitter feed. This is not the kind of place, because they're public, this is not the place where you're going to have widgets flashing red when your database cluster catches fire. These are just for high-level information. They're kind of a bit wishy-washy, but they're more of a marketing kind of PR thing. So looking at these different dashboards, in terms of analytics and status, they're not really the issue. It's quite easy to solve those problems. You can easily fire up Nagios, Graphite, quickly start monitoring these things, get the information out of your system. The problem we kind of found was that keeping people in touch with the actual reality, whether they're managers, developers, operations, trying to get them focused, working on the right thing, and knowing what the right thing is, was the kind of hard thing. Surviving in business, especially as a startup, is really quite difficult. If you spend too much time working on the wrong thing, you're kind of going to die, or unless you're extremely lucky. And so when I think about the different teams I've worked on over the years, there's been several different kind of methodologies, types of applications. So I suppose the first one was the old school classic kind of style of deploy to development works on the problem, gets deployed into staging, goes into production. It's really very much chuck it over the wall. Developer will work on his feature, test it locally, throw it over the wall. Tester will then, fail it for whatever reason. It gets chucked back, and there's a lot of back and forth. The next one was the agile, lean, Kanban, Scrum kind of stuff, which was, again, quite dogmatic. It was originally, it seemed to be there to get people to not have this kind of crunch at release time where everyone's just trying to meet the deadline and they've not kind of staggered their work properly. But then what actually happens is everyone turns into an agile evangelist and kind of comments on how you're not wording your stories correctly or you're not allocating the correct number of story points. And it didn't feel like the right focus. The other one is I've worked in teams where it's very sales driven. Sales or product management will kind of scream at you, you need a feature to make a sale in the Far East or wherever. You'll spend a couple of days, couple of weeks building that, deliver it, and then it's too late. They need something else now, we're moved on, or it's not that important. The different types of applications we worked on is, again, on-premise type, very long release cycles, 3, 4, 6 months, even though most of the work for those releases were done in 2 weeks before the deadline. There's the kind of hybrid on-premise cloud application, which is actually kind of a bit all too common for what you would think, where a company, well, especially like 5-6 years ago, would take their on-premise application, see this new cloud thing, and be great, yeah, I want that. So they would just take their existing on-premise application and pretty much just dump it into the cloud. Obviously, it doesn't work too well, it doesn't really scale. And yeah, getting resources allocated to that we found was the toughest problem. And then you get the SaaS applications where you just ship it as fast as possible. These are, from my experience, an order of magnitude harder. You're constantly releasing, trying to work on new features, trying to support the existing application scaling as you're getting new users if you're successful. Yeah, very hard. And then the startup, this isn't really a application type, but it's worth mentioning that it's just kind of free-for-all, fighting to stay alive, and can trick people into using your application, like doing everything you can, and staying focused in that field is really difficult. And none of these really, nobody was ever really geared towards focusing on the correct things. So, whoa, sorry. So yeah, if you're not working on the right things at the right point in time, then you're kind of wasting your effort. You're creating churn. You're adding instability when you could be working on the correct things. Delivering value is a very important thing. You can deliver a feature. It might be the coolest feature, the most amazing feature ever. If nobody's asking for it, if it's not going to bring value to the customer, you're just adding extra code into the application, which again is risk, add instability. Yeah, you could be the most amazing team, bang out all of the features that everyone's asking for, but if you've got some performance issues in your application, if it takes 40 seconds to log into your application, you're kind of failing. So some of the things we noticed that traditionally developers were very much rewarded by the features they delivered and how quickly they delivered them. So they were very much drilled down into fixing the issues, playing around with technology, getting their particular features done on their box and pushed out. Ops were obviously rewarded via sleep, but uptime. So they were concentrated on making the solution bulletproof, removing any single points of failure, trying to just keep the system stable and running. And then in this case, the product managers don't really help because they just want features. They want the features out there so that they can make sales. And they kind of lose track of performance a lot of the time. So when it comes to looking at what you should be working on, this can get really opinionated. Everyone's got an opinion on we should be working on this feature. We should probably be improving the performance of search, etc., etc. But we kind of have a lot of data in our applications which can drive these decisions, or in our applications and our business in general, which we should be making use of. Opinions are useful, but we should probably be using them for actually solving and working on the particular tasks that need to be worked on. And then they're actually testable as well. So if you've got a performance problem, you've got a graph there that shows you've got a performance problem, you can deploy a fix for that. And then if the graph doesn't fluctuate or fluctuates in the wrong way, your test failed. You need to try something else. So solution. We think dashboards is a good solution for this. But different types of dashboards to the standard analytics and status dashboards. Ones that you can use to drive change in people's behavior and drive change in the business. Again, people get dogmatic about these types of advice and things, but there's not really any silver bullets. This is kind of just what we've done and kind of stuff we've learned and how we operate as a company. We try to get the data out of the application, out of the rest of the areas of the business, and put it in front of the people's faces who are making these decisions, kind of try and ram it down the throat as much as possible. So we have sets of stability dashboards. So we monitor the general performance of individual services in our application. We also monitor the performance of things that we know are probably general trouble spots in the application, maybe not performing as well, then maybe there's a bit of technical debt in there. These stability dashboards, this approach doesn't need to be perfect. We don't have to get to 100% stable, everything's working, gleaming before we can move on and work on features, but it gives us an idea. So if a customer's complaining about a particular issue, and it might be changing part of your user profile, if it's a bit slow to do that, it's not the most critical part of the application. There's probably different things that we can prioritize above that. But if it's taking 5 minutes to change your username or something, then that's probably something that needs looking at. One example of this, in a previous company, there was an issue in the application which was fairly badly affecting the user experience. But due to allocation of resources and how the kind of politics worked out, it was really difficult to be able to get someone to address this problem, no matter who we spoke to and who we kind of told about the actual issues and tried to demonstrate to them. So the way we tackled this problem was we set up a monitoring dashboard for this particular issue, monitored the hell out of it, and then every Monday morning we automated a job to send out an email to the management team. This went out at 9 a.m. on a Monday morning, just before their weekly management calls. And then within 2 weeks, the issue was fixed. We got the information from where it was hiding in the service and put it in front of the people that could make those decisions. We also have feature dashboards, which don't tend to be the traditional dashboards you get. We have a public forum set up, so people can go on there, tend to be users, but anyone really, developers, product management can go on there, raise feature requests, raise issues that they want fixing or they think should work differently, and then different users of the forum can go and upvote those, and then that gives us not just an initial impression of what people are asking for, but there's a lot of people asking for these, then we know to prioritize those as features to work on. We also use user analytics, so look at how people are using our application to drive the decisions we make when it comes to prioritizing different features. Again, yeah, these are not traditional dashboards, but they do the job of getting information from the business and from the customer in front of the developers and product managers who are making decisions about what to work on next. We have some release dashboards as well. So when we kind of first started out, we kind of went down a traditional approach of developer works on a feature, gets pushed into staging, gets some testing, and once it's been tested and everyone's happy with it, passes on automated tests, gets pushed into production. There was two reasons that this become an issue. The risk impact for these started to slow things down. So the developer would work on the task, but locally they'd have their own data set. They might import some data to get something like maybe the load that's on staging, but it would never be what's in production. That would then get pushed into testing. The person that was responsible for testing it, they would not really have any idea of what the impact of that change. It might be a single line code change, but unless they knew the code, which they wouldn't really, they didn't know what impact that might have. So they didn't know how thoroughly to test it, or what level to go to. Obviously, we had automated tests around that, but there was still some risk. Because of this uncertainty around how much testing to do, it tends to slow things down. Everything had to go through the testing bottleneck. And because developers were just building the features and throwing them into the next stage, they were churning through features really quickly, and there was a big backlog. So there might be features pushed into staging, and then there would be so much that needed testing, it would slow down how quickly we could then take that as a release and push it through into production. And yeah, just the general feedback loop. So if there were several commits into your release, you wouldn't know which one has caused an issue, whether it was there beforehand, it had just come to light. So getting that feedback loop back to the developers if they had moved on to the next task was kind of unwieldy. So we kind of flipped it around. So now developers own the features. They're responsible for taking the task, building it, doing the work, and then they raise a pull request in GitHub. They get people to review it, so they will actually actively go after people and get them to review their code. So if they think it's a relatively low impact, they might just get someone to kind of have a quick look at it. If it is a fairly substantial change, they'll get someone who's the most knowledgeable in that particular part of the code to review it. Probably get several people to look over it as well. Once they're happy that it's been tested in the running application by automated tests and the code's been reviewed, then they can push it through into staging, through that pipeline. Again, they make sure it gets tested in staging and signed off, and then pushed through into production. Using this approach, the operations guys never do deploys. It's always developers that push those through. So there's always that developer there when it starts to cause issues, if there's a problem with that particular build. And we have dashboards set up for monitoring that pipeline. So this is quite an old one because we've got so many services now, it wouldn't really be easy to view on the screen. But you can see a build going through the system. We've got an environment called Nagios, which is our tool, but we use that for monitoring production. And yeah, you can see the builds for the different types of services as they get pushed through. We also have a dashboard for Jenkins. Unfortunately, we use Jenkins, but I don't have to look at it or maintain it, so it's fine. Yeah, so this dashboard is critical as well. If a build gets pushed through into staging or into production, and the build fails or anything goes wrong, any of those tests fails, we immediately stop, and everyone has to get that fixed and get that pushed through or reverted back out of the code. It's not often that everyone needs to jump on that. Usually just the person pushing it through, but it could be a build that highlights a different bug that was kind of hiding. So that pipeline has to get cleared because you can't have two builds going through the pipeline at once. So we have to get, once one's committed into the code base, into the master, then it has to get pushed through into production or taken back out again. To do this, there's kind of several things that we really needed to get this to work. So we have Chef running that throughout our stack, and we use Ansible for automating the deploys out through to the different environments. We also have native package deployments. So the code gets bundled up into a Debian package, and that's responsible for tearing down the code, tearing down the existing version, and deploying the latest version. That helps us for doing a clean deploy. So we're not at the point yet where we can have everything running at AWS and just fire up new boxes all the time. So we have to make sure we're completely ripping down the old version of the code before we deploy the new stuff. This also helps for rollbacks. So if there's any problem, we can just revert the code back. There was kind of some sticky points, mostly around developers when we tried to roll out this change. Like, it was quite a scary thing to do, like start telling people that just worked on the UI, you've got to now push your stuff into production. They were kind of quite worried about breaking stuff. So with that reassurance that they can just roll back in the worst case scenario, when they're deploying features, they tend to be during the workday anyway. So there's always people on hand to help. And it also encouraged positive change because it made developers release stuff in smaller incremental chunks because they knew if they broke it, they would have to fix it or roll back. So because they were reducing the size, it reduced the risk. We have some kind of monitoring driven development things. I hate these kind of buzzwordy things, but we use our monitoring as an enhancement on top of automated testing. So we have unit tests and functional tests, but they're all useful, obviously, but there's no place like production. So every service that we create has to be monitorable. So that means exposing a HTTP endpoint, and we use StatsD as well. So developers can put metrics, spit out metrics from the code at quite high velocity using StatsD. And obviously, yeah, production data is a lot better test than any kind of local test that you can do. An example of this also is one of our customers. So when called DevOps guys, when the Ghost vulnerability come out, they used Dataloop to patch that across their infrastructure. So they logged into the application, created a quick check in the app. They then worked out they basically deployed it across their entire infrastructure. Obviously tested it, deployed it out through the application. When data started coming back in as a result of this check, they then knocked up a quick dashboard. So this is their kind of TDD style. Here's the check to prove the problem. They then started rolling out the patch across the boxes in their standard way they would do it. And then they could see the check starting to pass that the vulnerability had been patched. And then once their entire infrastructure was done, they could see it in a dashboard. The dashboard was stayed around even after everything was patched. It was used as a regression test. So if anyone reverted a version, deployed a version of the OS that had the vulnerability, it would automatically get detected in here, and they would have an alert trigger as a result of that. So they were kind of covered through the deployment, and they had regression tests there in case it kind of went wrong again. So that's all I've got, really. The summary really is use dashboards, leverage the data that's in your organization and in your application. It's invaluable, really. There's so much there. If you've got the tools to get it out, then it's worth using and throwing out the people that can make use of it or make the important decisions. If you want to try a data loop, go to the website, sign up, give it a crack. I'm Colin Hemmings on Twitter. Also, like everyone else, we're hiring, especially if you know Erlang. Erlang developers are really hard to hire. And yeah, if you're interested in solving interesting problems, working at some scale, yeah, come and speak to me. Or if you just want to talk about monitoring, come talk to me. Questions?
Thank you. We got time for some questions?
Okay, sure.
The slide you had for Jenkins, what is all the information you have on there? Is that like the last build?
Yeah. So we've got just how long it's taken. So we do get issues where, for random reasons, the build will take forever to get built. Stuff will start going wrong. So this is just a general. Only look at this dashboard for any red. The ops guys set this up. It's basically status of the builds as they come through. What the build number is that just got pushed out. So when we get the build number, so when we merge the pull request that's been signed off, that automatically kicks off a build. Jenkins will spit out a Debian package. We can take that then and then use Ansible to deploy that across our different environments. Sure.
There was a claim many years ago by an on-call Google engineer that said that his point was you shouldn't necessarily alert or monitor your application based on figures, but on journeys. That your users don't care if your database is down; they care that they can't do something.
Mm-hmm.
And there seems to be a massive prevalence still towards analytics as numbers as opposed to journeys and business value. Is that just because it's hard, or because we're engineers?
Okay, so the question was, monitoring seems to be taken from value as opposed to a journey for a user. So you might be monitoring your database, and user won't care about that. They care about if they can't log into the application or buy something. Yes, I guess it's a mixture. Monitoring every user flow through the application is really hard, especially if you've tried using Selenium. I think you need a kind of balance. You're never going to get your monitoring completely perfect. You're never going to get your testing perfect. Like having 100% test coverage doesn't mean you're covered. I think you have to be pragmatic about it, really. You know which areas are causing issues. You know which user journeys might be affected by that. And so, we kind of take it as the issues come in. So if a user's reporting a problem, we'll probably start monitoring that if we're not already monitoring it, and then have some checks around that. So there's not really any, concise way, like definitive way of doing this. You just kind of have to be pragmatic, I guess. Sure.
It's business specific. We talked to tons of customers who, you look at Netflix or Amazon, like they fail fast on orders per second dropping unknowingly, or Netflix, number of streams per second drops unknowingly. Like you have to debug the infrastructure that's actually behind that, but you have to be monitoring business metrics that are specific to your business in real time.
Yeah.
We talked to a ton of customers who are moving in that direction, and I think that's definitely something.
There's also a lot of talk about anomaly detection as well in monitoring, but
Can you repeat the question?
it wasn't really a question. It was just kind of reiterating and talking on that kind of. Where he was saying it's kind of really business specific. kind of people have different problems depending on their type of business. Yeah, there's quite a lot of talk around anomaly detection and monitoring and how we can do that. But again, it's a tough problem. It's like AI, right? It's really, really kind of difficult to do. And apart from general pattern matching, it's a tough problem for people that are way above my head. Sure.
You talked about stability beats features.
Right.
This is normally like a real contentious point when if you're doing like sprints, things like that, like how to playing down tech debt versus features, especially when you've got the business, which generally attaches kind of more business value with features. I mean, you said stability beats features. Is that really like that simple? I mean, you must have some kind of conflict. And then I guess what you're kind of aiming at with this talk is actually exposing a lot of those metrics to the business people so you can make more informed decisions. Is that what it's about? Do you still have those problems?
Yeah, so the question was, we talked about stability beats features. Obviously, it's not usually as clear as that. And the business tend to want features over stability. In general, I also wouldn't get technical debt and stability confused. They're kind of linked, but you can have a lot of technical debt and your application be really stable, but you just don't want to touch it. It tends to slow down how quickly you can release features. So, yeah, in general, so if your application or parts of your application are unusable, in that particular case, you have to address those before you can start adding features. Yeah, it doesn't matter how many kind of cool features you have if it's not usable. But again, you have to make a judgment on that. If a user's saying it's unusable, then it might be a part of the application that's hardly touched. So you can prioritize that accordingly. But in those situations, we're always monitoring those complaint points. So if they do suddenly get worse, we can then react to that. I hope that answers your question.
So while the next speaker is over, because I don't know where he is, we have time for one last question.
Okay. Sure.
Hey, so I think it comes back to kind of the business and user journey stuff. Do you have designers on the team and user experience people? So like, if we look at this, there's a lot of information there.
Mm-hmm.
And do you have people in the team that help kind of distill things and help customers come up with useful dashboards?
Yes, so do we have members of the team who are UI-specific front-end guys who help our customers come up with dashboards and getting the information
How
out?
do you communicate the most effectively then, instead of having a bunch of data there?
Us internally or get our customers to do
Or
it?
for you, internally, for your customers, is that something about the product?
Okay, so yes, we do have UX guys. We have UX guys working on building we're actually in the process of doing a new UI at the moment. So obviously being a startup is like a bad version that we release and then there's a new version. So yeah, UI guys are working on that. In terms of building dashboards, they're not really, so the UI guys make sure we can build beautiful dashboards. In terms of building useful dashboards, we have, like sales support guys. These are DevOps guys in our team that will work with customers to help them get set up and get the right information out of there. But they're not UX guys, they're DevOps, ops guys who know what they should be looking for and how to get issues, how to highlight problems in those particular services. And also, from a business perspective, they know how to get that information out as well. So it's mostly really what checks they need to write and then how to make the dashboards look cool. Okay.
Thank you.
Cheers, thank you.